Hello everyone, in this video we are going to discuss the next three questions of the past year paper 2019 Feb-March paper 1, that is 1 2. So here's the question number 4. A curve has equation y is equal to 2x minus 1 inverse plus 2x, and we need to find dy over dx and d2y over dx square. So first of all we'll find dy over dx. We can see it is a chain rule, so it is minus 1 times 2x minus 1 to the power minus 1 into minus 1 and minus 1, and multiply by the differentiation of this, which is 2, plus 2x. Differentiation of 2x is only 2, and hence it can be written as minus 2 times 2x minus 1 to the power minus 2 plus 2. We can see it can be gone down, so it can be written as minus 2 over 2x minus 1 square plus 2, and d2y over dx square is going to be, I'll differentiate with the help of this term, and it is going to be minus 2 into minus 2 and then 2x minus 1 to the power minus 3, and multiply by the differentiation, again chain rule, so multiply by the differentiation of 2x minus 1, which is 2 plus 0, which can be written as 4 over 2x minus 1, 2 to the 4 to the 8, sorry, it is 8, and this is going to be power 3 because it is minus 3. So that's it. Now that is the 8 over 2x minus 1 to the power 3. I hope it is clear. Let's do the next part of it. In this, find the x of the stationary points, and showing all the necessary working, determine the nature of each stationary point. So for a stationary point, dy over dx should be equal to 0. It means minus 2 over 2x minus 1 to the power 2 plus 2 should be equal to 0. I can cancel 2 from everywhere and I'll get it as minus 1 over 2x minus 1 whole square plus 1 is equal to 0. I can transfer it this 1 over and right hand side and multiply by this. I'll get it as 2x minus 1 whole square is equal to minus 1. Minus will be here also, so it can be cancelled, and hence we get 2x minus 1 is equal to plus minus root 1, that is plus minus 1, and hence we got x is equal to 2x is equal to 1 plus 1, or 2x is equal to 1 minus 1 plus 1, that is 0. So we got x is equal to 1 or 0. So for these two x we have to check for the stationary point, because they at x is equal to 1 and x equal to 0 we have the stationary point for the function, but we have to check the nature with the help of d2y over dx square. So d2y over dx square at x is equal to 1. So what was d2y over dx square? It was 8 over 2x minus 1 to the power 3. So at x is equal to 1 it is going to be 2 minus 1, that is 1. 1 cube is 1, so it is positive. Hence at x is equal to 1, graph is or function has its minimum value, and at d2y, let me scroll off, and at d2y over dx square at x is equal to 0 we'll get 8 over 0 minus 1, that is minus 1, whole cube is minus, so it is going to be minus negative. Hence at x is equal to 0, function or graph has its maxima. I hope it is clear. You can see everything is very in a fixed manner. Dy over dx should be equal to 0 and you will get x values, and for that x value you will check for d2y over dx square, the second derivative, and if it is positive then you will get the minimum value, if it is negative then it is maximum value. So I hope it is okay. That let's do the next. This is the question number 5. two vectors u and v are such that u is equal to q to 6, 8 q minus 1 q square minus 7. Q is a constant. Find the values of k for which u is perpendicular to v. So if u and v are perpendicular, if they are perpendicular, it means their dot product should be equal to 0, because we know that dot product of any two value u and v will be magnitude of u into magnitude of v into cos of theta, the angle between them. So if theta is 90 degree, this will become 0, and hence we are going to find the u dot v and make it equal to 0. So q2, and it is q to 6 dot product. I'll write like this, though you can write directly u dot v is equal to and 8 q minus 1 and q square minus 7 is equal to q into 8, 8q plus 2 into q minus 1, that is 2q minus 2, and plus 6 into q square minus 7, that is 6q square minus 42 is equal to 0. Now it's a quadratic equation, so let's make it in the standard form. That is 6q square, 8 plus 2 10, 10q minus 42 is equal to 0. It is 44 is equal to 0. So we are going to divide by 2 throughout, so that we'll get 3q square plus 5q minus 22 is equal to 0. Now we need to choose two number by which we'll multiply to get 66, and when you subtract we get 11. So we'll get 5. So 66 and by multiplication and subtraction we should get 5. So 11 and 6 I can see. It is going to be 3q square plus 11q minus 6q minus 22 is equal to 0, and hence it minus 11 is equal to 0. So we can write it as 3q plus 11 into q minus 2 is equal to 0, and hence we got two values of q. One is 2, another is minus 11 over 3. So these are the values of q for which these two vectors are perpendicular. So the answer is q is equal to 2 or q is equal to minus 11 over 3. Let's do the next part. Here's the second part of it. Find the angle between u and v when q is equal to 0. So I'll write u and v again. U is equal to, earlier it was, so at when q is equal to 0, u is equal to 0 to 6 and v is equal to 8 minus 1 minus 7. So if we want to find the angle, we'll use the dot product. So for that, first of all you will find what is u dot v. It is 0 into 8 0 plus 2 into minus 1 minus 2 plus 6 into minus 7 is minus 42, that is minus 44. We got dot product of it, and we'll find the magnitude of u and magnitude of v modulus, and that is going to be square root of 0 plus 4 plus 36, that is 40, and modulus of v is going to be square root of 8 square, that is 64, plus 1 plus 49, 49 plus 150, 50 60 is 110, and 4 114. So now we have u, v and magnitude and their dot product, so we can get cos theta, the angle between them. Let's say the angle between them is theta, so cos theta is going to be u dot v minus 44 over magnitude of u, that is root 40, and magnitude of v is, that is 114, and hence it is minus 44 over 40 into 114, and hence we get cos of theta, theta is equal to cos of cos inverse of this minus 44 over root 40 into 114. Let's calculate what is that. It is 130.66 and so on. So the angle between U and V is 130.7 because we need to give the answer till one decimal place in the case of angle. I hope it is clear. Here's the sixth question, first part. The first and the second terms of a geometric progression are P and 2P. So we know common ratio R is second term upon first term, and that is 2. We have second common ratio as 2 and first term A as P. And now where P is a positive constant, the sum of the first n term is greater than this. So Sn is greater than 1000 times P. So we need to show that 2 raised to the power n is greater than 1001. So let's put the value of it. We know that 2 is greater than 1, so Sn formula will be A into r to the power n minus 1 upon r minus 1, and that should be greater than 1000 P. And let's put the value, and we'll get P into 2 raised to the power n minus 1 over 2 minus 1 is 1 greater than 1000 P, and hence we got it as 2 raised to the power n P minus P is greater than 1000 P, or we'll transfer P that side and we'll get 2 raised to the power n times P is greater than 1001 times P. P is, since it is a positive constant, so we can cancel it and inequality will be same, and hence we have shown 2 raised to the power n is always greater than 1001. I hope it is okay. Let's do the next part. Here's the second part of the sixth question. In another case, P and 2P are the first and second term respectively of an arithmetic progression. If it is arithmetic progression, A is P and common difference D is 2P minus P, that is P only. And the nth term is 336 and the sum of n terms is 7224. Write down two equations in n and hence find the values of P and N. So what are the things given? Un is given as 336 and Sn is given as 7224. So let's put the value. We know that Un is A plus N minus 1 into D, that is 336, and which can be written as A is P plus N minus 1 into P is equal to 336, or I'll simplify it, we'll get NP is equal to, because P and minus P will be cancelled, is equal to 336, and from here Sn is n by 2 times 2A plus n minus 1 into D, it is equal to 7224. So let's put the value, and from here we can make another equation. I'll mark it as equation number 1. From here we'll get it as n by 2, and we know it is 2A, so I'll write A plus it is A n minus 1 into D, that is 336 already given, it is equal to 7224, or we can write it as n into P plus 336 is equal to this into 2, 2 4s are 8, 4 2s are 2 2s are 4, 2 2s are 4, 7 2s are 14. So we got it as NP is equal to I'll write 336 n is equal to 14448. This is equation number 2, and from 1 and 2 we can see, from 1 and 2 we have NP from 1 is 336, so I'll write it here, 336 minus 336 n is equal to 14,448, and hence it is 336. N is equal to 336 minus, oh sorry, it is plus, I'm so sorry, it is plus, and it is, so it is plus. So 336 N is equal to 14,448 minus 336, which is 14,112, and hence N is equal to 14,112 over 336, and that is going to be 42. So once we have N value, we can get the value of P also. So P will be 336 over 42 from 1, because from here NP is 3 into 3, 336, so P will be 336 over N, that is 42, and it is 8, and hence N is equal to 42, P is equal to 8. So I hope you must have understood all the things. Thank you so much.